Good afternoon, everyone. Shall we start? And good morning to those in Europe. Welcome to this webinar. I'm Bo Huang from the Laboratory of Computational Social Science, Faculty of Social Science, the Chinese University of Hong Kong. And today, I'm very pleased to have two professors from School of Architecture to present to us a webinar on computational and human-centric design methods in architecture and urbanism. And before they start, let me introduce the two professors briefly. Professor Adam Fingrut and Jeroen Ameijde are assistant professors at the School of Architecture, focusing on the integration of computational research and design methodologies in architecture and urban design. They were both co-chairs and co-editors of the 2021 International Conference and the Proceedings of the Association for Computer-Aided Architectural Design Research in Asia. Adam's research focuses on technology-driven design, fabrication, and assembly in architecture, and how it can impact on our future workforce, industry, and education. He is co-director of the Center for Robotic Construction and Architecture at CUHK. Jeroen's research focuses on the intersection between urban studies and urban design, and how the analysis and the planning of social, cultural, and economic activities can be guided through computational methods for urban analytics and data-driven design. And by the way, they are both faculty affiliates of the Computational Social Science Laboratory. Without further ado, let's welcome them.
Thank you. Thank you. Good afternoon. Can I start? Yeah. Good afternoon to everyone, and thanks to the Computational Social Science Laboratory at CUHK for the invitation to join and share for this webinar series. Okay. So the evolution of cellular phones since the 1970s shows how new technologies have often had the capacity to not just upgrade existing processes, but to revolutionize many aspects of our daily lives. We now have multifunctional platforms through which we communicate with the world, engaging with our ever-increasing range of data sources embedded within our environments.
These increasingly sophisticated technologies permeating buildings and cities offer exciting new opportunities for us to rethink how we can shape future environments around the living patterns of individuals and communities. Instead of the previous visions of future cities, which were filled with hyper buildings and flying cars, the cities of the future may actually look more familiar, but in reality are also more radical than what science fiction had predicted, seamlessly merging our physical and digital environments through the embedding of digital and robotic devices in and around the home, enhancing all types of logistics, play, and human interaction. Buildings becoming embedded with sensing and actuating systems that respond to individual user requirements in real time, monitoring and analyzing ways to increase efficiency and support productivity in a time when the ways in which we work need to be more flexible than ever.
So when everything is becoming digital, the role of the architect and urban designer is changing from that of a draftsman of standard solutions to a designer of complex environments that integrate ideas about space, structural, climate, infrastructure, addressing the lifespan and occupancy phase of buildings, and focusing on the design of user processes instead of that of just products.
New technologies allow us to incorporate a wide range of data, knowledge, and understanding, such as people's perception of space analyzed through computer vision, and allow us to conceive of buildings not as labor-intensive artifacts, but as digitally designed and fabricated kits of parts assembled onto sites using an integrated workflow that seamlessly connects our CAD software to the integrated building modeling software that controls construction.
So to operate in tomorrow's practice, we need to grasp the future of digital society. so that we grow to share awareness, skills, and digital literacy that can empower us to contribute to the transformation of our societies. Those 4 stages are related to the 4 levels of awareness of how we can analyze and translate data and information and develop a critical understanding as meta-knowledge of technical systems as a whole. As the speed of productivity and technology doubles every few years, organizations are often slower to adapt as they have to transform existing methods and workflows. Yet as the increasingly sophisticated interface between the digital and physical starts to impact many different aspects of our everyday lives, there is an urgent need to engage with technologies through design thinking, rather than letting developments be driven by engineers, managers, and corporations. Academics and designers are in a unique position to evaluate the tools and methods with which they perceive the world and how they organize and process information, and assess the interface between the analog and the digital world as the most critical aspect, as the feedback loops between the two are the current forefront of innovation.
An example of this is the installation titled Seek, developed by Negroponte in 1970, which housed small kangaroo-like animals in a plexiglass encased environment full of small blocks managed by a camera and a robotic arm. The installation proposes a new type of open-ended design process, which does not project a preconceived master plan, but aims to learn from the inhabitants' behavior. Through simple rules that analyze and manipulate the blocks, the system tries to help the inhabitants achieve their ideal 3D environment. And the role of the architect is not to design a fixed outcome, but a process that governs a system of human-centric design. The steps of this system are highly relevant still today, as the scanning and analysis of sites, interpretation and implementation of design interventions are at the basis of all new forms of data-driven design. Of key importance is the feedback loop between the evaluation of performance and the improvements of future design solutions. As these types of feedback loops are now applied to analysis of complex and big data, we can tap into the real complexities of urban ecologies. Instead of relying solely on the human designer, processes can be enhanced with digital knowledge systems that incorporate the real world needs of end users into designs for the built environment that are better fit for purpose.
Okay, so hello everybody, and thanks again to the social science faculty for the support of computational initiatives. My name is Fingrut, and I'm an assistant professor here at CUHK School of Architecture. My background is in computation and design. In particular, I have focused on design complexity approaches to execute mass variation in the built environment, executing construction and material efficiency. I'm co-director of the Center for Robotics in Construction and Architecture, a collaborative research center under Keystone Robotics Institute here at CUHK, where we conduct collaborative research on mechanical automation and architecture, linking material science, engineering, computational architecture, design, and construction. Also focusing on educating the public through demonstration projects. And we link our research with industry through the development and execution of real-world construction projects. And I'm also involved in the education of computation and automation with our UG and PG students, linking innovative technology with pedagogy and approaches toward design thinking.
Yes, and hello everyone. My name is Jeroen van Ameijde. I'm a new assistant professor since 2.5 years here in CUHK, previously being working and living in London. My background is in both academia and practice, teaching part-time and working on projects of various scales since 2002. I've always been interested in the overlap between architecture and urbanism and how buildings shape public spaces and connectivity within their context. And my background also is in designing master plans, which has specifically focused my attention to the design of underlying organizational structures, and how the growth and development of urban areas can be guided by new processes of generative design, and how through the design for instance, projects of mass housing, we can develop digital tools that manage non-standard configurations in an affordable way. This has fueled my interest in the standard and non-standard as being used in Hong Kong's public housing and how estate layouts balance between density and livability. And my current research uses computational analysis of in-between spaces in public housing, which combined with the analysis of people's daily activity patterns, can hopefully lead to evidence-based design guidelines for estate layouts to better support social capital and the sense of community. So last month, we had the honor to host here at CUHK the 26th International Conference of the Association for Computer-Aided Architectural Design Research in Asia, or CADRIA. And themed projections, we invited speakers, roundtable participants, and paper submissions, which would reflect on the different ways in which innovation can impact the quality of future built environments.
The conference annually attracts a large number of papers from all the major universities across Asia and the Pacific region. And since conferences and webinars are now held online, also, well, yeah, I guess that says webinars, also from many other parts of the world. CADRIA website had over 96,000 visits from nearly 28,000 unique visitors. The proceedings for which we were both editors include 148 papers on topics ranging from innovative construction to urban analytics, published in 2 volumes of 700 pages each and indexed online. Our keynotes and roundtables highlighted the design opportunities and efficiency gains from fully digital workflows, integrating collaborative work from multiple disciplines and stakeholders, with engineering industry specialists noting a shift towards information management services, highlighting the need for international standards for the exchange of complex data sets.
And renowned architect Ben van Berkel talked about his new subsidiary company, UN-Sense, which focuses on artificial intelligence and digital sensor technologies to create human-centric buildings and cities. Several architects, academics, and industry specialists involved in robotics talked about a paradigm shift in the production chain in the housing industry, where a shift from centralized to distributed decision-making could give homeowners more control over the design or adaptation of their living environments.
Professor Carlo Ratti from MIT showed the opportunities that emerge around scanning cities from roads or canals, collecting environmental data to inform policy decisions. As our international panel of urbanists agrees that an urgent rethinking of city planning is needed in relation to a deeper understanding of regional and global ecosystems, which was reinforced by architect and filmmaker Liam Young, who showed a speculative future city for 10 billion people, exploring hyperdensity as the only feasible scenario to balance urban development with planetary health.
For people interested in this research, all the lectures as well as 30 parallel paper sessions will be available online soon. And already now, all the papers with their abstracts, full paper PDF, and 10-minute presentation videos can be accessed on this website.
Okay. In Hong Kong and internationally, the scope of construction projects continues to rapidly grow, creating a shortage of skilled workers to support demand. For example, in 2013, over half of registered construction workers in Hong Kong were over the age of 50. In 2018, the Hong Kong Development Bureau created Construction 2.0 that responded to this need, along with a major upgrade to the industry cross-section. Under this new agenda, 3 key priorities for quantitative performance improvements were advanced: innovation, professionalism, and revitalization. The Hong Kong Construction Industry Council followed suit with a more detailed breakdown of local industry development, listing building information modeling, BIM as it's known, safety, modular integrated construction, construction productivity, and sustainability. And this can translate into digitization of things, increased training, assembly line quality control, automation, green construction, and inhabitation or occupation. I'm now going to show a few projects of mine that relate to these initiatives. The Golden Moon was a 2012 project in Causeway Bay. It was a 20-meter high dome clad in bamboo and over 400 fabric flames with a 1 megapixel light. It served as a cultural icon for the city, and as part of the Mid-Autumn Festival celebrations, accommodated over 400,000 visitors in under 6 days. After all the conceptual work, this became a real question for the project: how to accomplish geometric complexity, variety, and visual interest in the built environment with low-skilled labor in lightning fast speed. by using the power of mathematics, computation, and digital tools at our disposal, we're able to rethink the geometry and overlay a complex grid atop a generic structural system. Here we're using a method called sphere packing, which can calculate the optimum spacing and radius of an area on any given surface. It allowed us to populate our dome in a more complex and dynamic way. The assembly concept was straightforward. Install a heavy steel and concrete base, add a prefabricated dome here, wrap it with bamboo, and finally decorate with 500 unique lights. Give me a second. There we go. There we go. Okay. For this to work, notation is everything. It's the conduit between data models and the physical output. And here you see the dome being raised. And bamboo materials were measured and notated based on their intersection points along the sphere, making assembly on the structure straightforward without conventional drawings. And the bamboo diagrid forming over the structure. And a flexible system using stretch fabric and bamboo was used for each flame or light diffuser. Here we see the first diffusers and LED lights getting installed. Some images of the final construction. And the Zcb Bamboo Pavilion is a 30-meter spanning, lightweight, and bending active grid shell completed in Hong Kong in September 2015 as a public event space. It's built from unprocessed bamboo poles, hand-tied together according to traditional Cantonese bamboo scaffolding craftsmanship, and covered with tensile fabric. The project is very much a case study for the computational design and building information modeling of structures where both applied materials and available craftsmanship are highly unpredictable in terms of accuracy and precision. It was our goal to narrow that relationship for an accurate outcome. You can see how it compares in size to traditional bamboo temporary structures. It uses considerably less material as it capitalizes on the bending strength of the material. The project site in Kowloon Bay near the Mega Box. Extensive use of physical and digital models were needed in a variety of different scales. There's the primary investigator to test all of the project, order of operations, etc. And these became main reference points on the site as well. Digital models allowed us to manipulate and extract critical data such as lengths of material and cross-connection points, and predict material procurement such as the fabric covering. Here you see the bamboo laid out on the site and the first concrete plinth being poured. Each pre-measured length of bamboo would be assembled and then installed into place with traditional ties at those connection points. The order of operations would have to be simulated within the digital environment and tested through physical modeling in coordination with consultants and construction teams. While conventional architecture drawings may look similar to this top view image, our notation is slightly different. It's about lengths and connection points. So this allowed for drawings that look more like this, a linear readout of data based on a collection of objects that overlap one another. In this case, you're looking at standard measurements of bamboo material, a variable for overlap between them, and a series of connection points where other bamboo poles intersect. And this exact set of drawings was used to lay out bamboo poles on a giant 50-meter long table. And the material was measured according to what was notated, and the cross-connection points were marked off later for reference during assembly. Here you can see the very first pole being installed into place with temporary scaffolding in the background, and fixing to the concrete plinth and footings. 910 square meters of fabric were also applied. And workers measured the as-built structure and entered the length of data into mobile phones using spreadsheet applications, resulting in unfolded drawings like this that could accurately be applied to the as-built structure. Material was then cut and fabricated in a factory setting using robotic cutters, and heat welded into place based on those digital drawings. Material was then hoisted into place and fastened to the structure in one super tailored surface. and some images of the final result. And of course, we're able to 3D laser scan the entire structure and test for final deviation from design, computer model, and as-built construction. And a little bit about robotics and what I do with CUHK. This research discusses the assembly of brick structures with a cable-driven parallel robot, explores the impact of computational design tools and the deployment of robotic equipment for the creation of an expanded architectural design space based on the limits of material and equipment in place of a skilled labor force. Bricks and bricklaying have been a part of architecture and our built environment for centuries. And the industry relies on intensive specialist on-site labor. Other research has explored the use of long arms, but they're quite heavy or have limited mobility. Our research in the use of cable-driven robotics are lightweight systems that can span over large distances. The setup allows the gripper to reach a large three-dimensional working area in which bricks can be accurately placed. Using input parameters such as guide curves and brick dimensions, brick coordinate information is generated for further processing. So if you think back to our notation, now it's really just a spreadsheet of data transferred to a robotic arm. And geometrically complex spatial structures are possible with undulating walls. This research has been displayed in a variety of industry events, workshops, and museums. And over the years, the system has undergone a number of significant upgrades and advancements in strength, accuracy, and endurance. Automated placement, order, stronger gripper motors, stronger cable system, increased precision. On the design programming side, we add intelligent placement order for more stable structures. We currently have an updated version of the system on display at the Hong Kong Science Museum and TST as part of their exhibition on robotics. This particular system was designed to be on a continuous loop, and we're using lightweight wood for bricks. So here you can see the gripper placing a small, relatively safe structure for display purposes. And I think it's been running for over 3 months around, with not too many hitches. Yeah. And finally, the Yard of Environmental Sustainability project is part of the CUHK Recycling and Sustainable Campus Initiative. This structure, set to be completed this summer, will house a recycling depot for staff and students. The project is also a new space for students and staff to visit and relax. Located along the central avenue of our main campus. Here you can see a laser scan of the site with previous designs for recycling bins, clothing, electronics. The space will also include recycling for PVC banners, a free library, etc. The design intends to include accessibility standards, shaded areas, seating. And the project advances our research by placing it into a full-blown construction project with stakeholders, engineers, architects, landscape architects, contractors, building department, and of course, a generous client. And we are on site now, and we are in the final stages of testing before we kick off our final construction. And I'll pass it to Professor Ameijde.
Yeah, so Adam and myself have been working on slightly overlapping projects as we have been awarded separate and joint grants by the Hong Kong Construction Innovation Technology Fund, CITF, and the CUHK Teaching Development Grant Program, TDLEG. In this CITF supported research shown in this video, sorry, it was not playing. We explore the use of drone scanning in the conceptual design stage rather than using this for quality control during construction phases as is often used in industry. The idea is that the highly detailed and accurate site surveys can plug into a more informed and data-driven design process, which is normally based around simplified understanding of the context. Images captured by the drone are transformed into a 3D mesh in the modeling software commonly used by professionals and students in architecture and urban design. This process can be done in stages, even taking photos on foot and adding more detail where needed. Details such as building alterations, greenery, public space, materiality can be captured and inform a georeference and accurately calibrated 3D model, which can be used, for instance, for solar energy analysis to help understand which areas in the public space may be cooler in the summer in relation to the urban form. We can also perform visibility studies based on the principle of convexity, the blocking of line of sight, which increases the sense of privacy, but may also decrease the sense of safety and orientation in public space. And recent improvements in software and hardware computing now allow these studies to be done in 3 dimensions, visualizing different degrees of surveillance, or what Jane Jacobs famously called eyes on the street. So in a small test site on the CUHK campus, we can see where the most public spots are and speculate on placing new landscape elements that mediate privacy. And use the same photogrammetry model to do quick testing and visualization of design alternatives in the conceptual stage. A similar but more small scale and more detailed project is currently being developed in collaboration with various stakeholders at the Yao Oi public housing estate in Tuen Mun, where an existing public space is lacking shaded seating. So here we've done an overall site analysis of climate comfort and also various levels of seeing and being seen, identifying the spaces which have the most potential to improve social interaction between elderly residents of the neighboring estates. In this, what we call digital placemaking process, a canopy form is generated to maximize the shadow on existing 3 benches here, while also minimizing the use of materials. The project uses the principle of lightweight structures using a tension fabric, where the curvature helps to stabilize the canopy against the wind load scenarios. And you see an optimization process using genetic algorithms that automatically fine-tunes towards an optimized result, where you see the final solution being stabilized in the computer. The software automatically evaluates all design alternatives through a solar analysis and helps select a form that also improves privacy and stimulates conversation between different people through the principle of triangulation, as William White has called this. Currently being developed is a structural design adapted to the fabric rather than the other way around, optimizing a minimum amount of steel for a central frame, so that the project can be further developed with the help of fabricators who donate their expertise and time as part of this research project, as we're getting ready to install the first canopy on site in the coming months. The next project explores the linking of research and design at a larger scale, testing speculative redevelopment scenarios for Nam Shan Estate near Shakib Mei. This is a final year dissertation project by a student questioning why in Hong Kong we have such limited available public space, but also still many underused areas and facilities. He did extensive mapping with a team of colleague students to document various activities taking place and analyzing spaces with higher degrees of social interaction, categorizing these activities according to Maslow's hierarchy of needs pyramid, so that we may understand which public spaces can support physical, social needs, and also support personal development and self-actualization. This research combined different morphological analysis, such as surveillance again, but also accessibility, in this case based on space syntax methodologies of network integration, to classify the different spaces across the estate according to their social and physical characteristics. And allow for this kind of combined correlation mapping to understand why certain spaces are well used and other spaces are underused, and what the reasons for this may be. In a final stage of speculative design, the student tested a generative system for changing the building massing as part of a hypothetical redevelopment phase of the estate, where based on a list of desired spaces and relationship between them, which was found in the field studies and the analysis of those findings. He developed several testing scenarios of new buildings. One of these shown here, which has a double amount of building density, but still resulting in a central open area, which could serve as a flexible community space. So in our work, we referenced a lot the methodologies already in use by the Housing Authority, for instance, for the planning of improved microclimates. And also their advanced design and construction methods using different type of precast concrete elements. But we also find that the modular flat design currently in use has quite a limited catalog of options, especially in terms of the variation of spatial depth and hierarchy of the internal floor plan, which creates a lack of freedom for residents to choose how to engage with others in their household. While the forced social engagement might be good for some types of nuclear family, it may be limiting for new forms of co-living or live-work arrangements, which are increasing due to changes in society. For instance, especially recently during COVID pandemic. So this research explores how to incorporate more diverse user requirements into floor plan arrangements at the scale of a single apartment, and also at the scale of a combined floor plate where several customized apartments need to negotiate around access to the lift core, daylight, and ventilation at the facade perimeter. So we speculate how this approach could liberate further the current approach that is called non-standard housing, which have already resulted in more site-specific and environmentally sensitive estate layout designs, but in reality have an apartment mix which is still based on models of repetition. So in our current most recent work, we look at combining aerial surveillance with other types of urban data to test generative urban design process informed by site and context. So besides the photogrammetry and machine learning algorithms that we now can use to process this scanning data and classify different geometry groups, we can also use open source GIS data to collect, for instance, locations of points of interest on surrounding sites, and combine that with user density and popularity data sourced, for instance, from Google Maps. So we can map hotels and restaurant locations, and also the ratings and reviews from users to build up a comprehensive map of attraction points and potential visitor flows through the neighborhood. Incorporating all this in massing studies, so we can test not only the density of urban fabric, but also where we leave empty spaces for the flow of public and activities in relation to the surrounding context and urban fabric. So in my longer term research, we are trying to reinterpret Negroponte's architecture machine concept into a workflow that would enable participatory design in public housing estate open spaces. This is a current case study project we're also working on, Prosperous Garden Estate in Ameijde. Originally, we started working on this as part of a competition organized by the Housing Society and the Jockey Club, the Design Institute for Social Innovation. So we performed a 3D scan of this estate using both drone and terrestrial scanning to create a detailed 3D model documenting the various recreational spaces. And as a second part of the research, conducting a structured field observation with a team of student helpers to document activity types, locations, and durations across different times of the week and weekend days. To understand different densities of activities and project them into a digital model at the different height levels of the landscape in this estate, which can then be analyzed according to certain distance rules, for instance, based on proxemic interactions theory by Edward T. Hall, understanding personal, social distance, and therefore translate from a user-centric to a space-centric type of analysis, where we can understand the statistical occurrence of user presence and co-presence as a feature of the various locations. Further steps that are currently in progress is to develop a method which automatically analyzes people movements and activity densities within public space using machine learning algorithms and computer vision. So as most of this work is currently still in progress and hopefully will produce further results in the future, it is guided by the idea in between these two agendas shown here, which is working towards responsive environments in which technology can support a more human-centric approach to urban studies and urban design.
So just in our last section here, when we consider the initial question of this presentation, how can we prepare for and engage with the world that is becoming increasingly digital, we're developing a teaching strategy that combines design thinking and technology. As we refer back to the feedback loop diagram, we can break down this process into individual modules that can be taught separately or combined. Translated into basic architectural terms, we can introduce digital tools and innovative thinking around scan, design, and build.
So scan might, for instance, be an exercise for second-year students to analyze an image and use a sampling logic and a generative drawing system to create interpretive patterns. Or it might be a volumetric translation of human figures into an abstract composition of self-similar components, letting students learn basic skills of 3D modeling and composition.
Using high-resolution 3D scanners, students can capture intricate details and patterns. They can digitize things from the world they experience to create 3D models suitable for further experimentation, simulation, and analysis. And within intriguing sites, we can process scans that capture movement, helping to understand the movements of the body in relation to specific aspects of the physical or built environment. And then design thinking can be enhanced through new tools for visualization and communication. We link the collaborative design environment, like our architectural design studios, through virtual reality tools. And as part of a final presentation where reviewers can be given an immersive and interactive experience into three-dimensional space.
Design can be developed based on earlier scanning data using digital analysis to inform and test, for instance, elements that mediate privacy, testing out simple kits of parts systems that can assemble in different densities, responding to a site intervention strategy based on, for instance, diverting circulation and creating new opportunities for social interaction in a place that normally wouldn't let people have those kind of activities. And testing and developing a detailed and realistic representation of the context. Understanding, not just the buildings as form, but as performative systems in relation to the scale of the human body and looking at the interior perspective instead of the aerial view.
And another exciting part is we have access to small desktop robotic devices, and we can expose students to the same code being used on those big construction projects, but in a scaled down price and in a scaled down size. We can start to test real world assembly processes and explore creative possibilities around them. Even starting to test out machine vision and artificial intelligence is part of a pick and place workflow.
This allows to speculate around augmented construction sites with complex assemblies where the design is in a detailed manner responding to the analysis of social conditions within these existing environments, and then responding with designs that have a high resolution approach to social performance and incorporate the possibility to be endlessly reconfigured based on the ever-changing needs of the inhabitants. So in conclusion, as we formulate our own version for this webinar, maybe as an architecture, as a computational social science, we developed this around an agenda that moves away from classical mechanisms and reductionism, but instead embrace the notion of ecology, which instead of using static and isolated notions of problem solving, tries to understand the complex interactions between design solutions and people within environments that change over time.
This type of systems thinking, although technical in nature, is first and foremost based on human creativity and curiosity. As without design thinking, we would not be able to imagine and shape the world as we would like it to be. And I think that's
it. Yeah, thank you.
So thanks everyone very much.
Yeah, thank you very much. Excellent ensemble, providing very nice overview of their research work on computational architectural design. So now the floor is open for questions. So actually I got some questions from the chat window. So Professor Li Wei, are you going to ask question yourself or I ask for you?
Yes, I can ask myself.
Yeah, sure.
Yeah, thank you very much. The first about the bamboo structure. The material of bamboos, how to prevent the fire risk, and also it's the weather is very humid in Hong Kong. So how can prevent the bamboo from getting rot and to be unsafe? And for those countries like Nepal, they are like Japan. There are often earthquakes and tsunamis. So how to make this materials earthquake proof or tsunami proof and tornado proof? So that's the first question. The second question is for the open space design. I think it's very good in our university have this open space and also consider the privacy. Then how to use this open space, maximize the use for multi-purpose. I provide some ideas in my comments. So to save time, I don't speak in details. So you can see the chat. You can see we can develop some new project based on this.
I guess just to quickly answer your first kind of cluster of questions regarding the bamboo, probably the biggest problem with the bamboo was the UV rays. So in addition to treating the material with a kind of like boric acid, which is basically a kind of like a saltwater solution, which we heated up a big bathtub and then immersed it in that material. Traditionally, it's just done with seawater. But in addition to that, the biggest and most important thing for protecting the material was covering it up from the UV rays. So the surrounding buildings in Kowloon Bay, which is the mega box and a bunch of other very tall, very glass buildings, made it incredibly hot and dangerous for the material. So we had to keep it covered until it was finally covered with the other material as well. And regarding, I don't know how to respond to the earthquake question, but in terms of a typhoon, we did actually experience a typhoon during the construction period. And at 5 in the morning, I was completely terrified and split a taxi with Professor Krola, the primary investigator on the project. And we went over there. It was still dark and it was completely stable. And we were actually quite happy that it didn't blow away onto the highway.
Well, same as scaffolding
Sure.
theaters. So they're actually born out of the context. Right? So there's an inherent wisdom in the lightweight and resilient nature of those structures.
Yeah, I have some slides I can share with you another time of the typhoon, but we were limited, so yeah.
So thank you so much for your questions. Regarding the open space design testing, I think the most radical idea that we're developing in relation to how to maximize the use of the space to fulfill everybody's different requirements is to try to set up a process that opens up to user input, so that this is actually not done by one person or a designer in a way that it therefore becomes fixed as well, because our assumption is that we cannot know really what the requirements of the users will be, and they will also be continuously changing over time. So the strategy of using even these digital tools would be to continuously monitor the behavior and activities on site and let that continuously inform changes to, for instance, the street furniture, the boundary conditions such as fences or removing those, based on the analysis of the actual activities or what seems to be in demand. So the idea is to try to set up a system that automatically matches supply to demand, whatever that is, into the longer term future.
Thank you.
Okay, Jamie, do you have any question? Yeah, please.
Yes. First of all, it's a great presentation. Like I said, Adam, by the way, by this seminar, Adam and I were able to chat and share some interest. So I appreciate like this seminar and our faculty for this series. So I'm a social network scholar again, and I'm interested in like the social consequences of architecture, how architecture can shape our like social pattern of mobility. So in terms of this, like especially Jeroen's like data-driven urban design things were really like fantastic. Especially that part, like, identifying introvert and extrovert socialized places, right? That's what your students are doing. That is really, really interesting. And I believe like that could have lots of like implications for like social scientists like me, like about this. So, and I have a question about like Adam's project. It's related to also like Jeroen's data-driven approach. So you mentioned about like yes pavilion at CUHK, right?
Yes.
So what is like the underlying goal of the project? Like in terms of my perspective, like how like architecture can shape our like social mobility patterns, things like that. Do you have any like evaluation plan? Because I thought it would be extremely interesting to see like what kind of like the social patterns can emerge due to that establishment of the like special kind of pavilion. But I see that like the Jeroen's approach, like the image captures and like solar energy analysis can be combined with such evaluation of the like the new place, right? Because if the project has a goal, then you need to evaluate. I think that's why it's the right way to use such like solar energy analysis. Yes. So that is my question, but also related to that, like, so you use extensively the data-driven urban design approach, but do you have any like privacy concerns while you are doing research? Because like you literally like fill all the things and gather the data. Probably there could be some identified problem. So yeah, I'm not really like questioning like how you do it well, but what are the general challenges and how you have been addressing them? It would be awesome to know about that. So there's one question and two questions and
great questions and comments. Thank you so much for that. And of course, we have a lot of privacy concerns, and I think actually one of the motivations of doing this kind of work of understanding new kind of systems of surveillance of for instance, image recognition and analysis of public spaces is to actually address these upcoming technologies and to take a position as architects and urban designers, because if we don't address this, then these technologies will anyway be further developed to a state where maybe we are no longer part of the conversation. So I think this is a very urgent topic to think about and even talk about with students. For the research, of course, we have to do a full, actually my last GRF application went through a full ethics application and not even the short one, just because We're proposing to bring cameras into public housing estate sites. And we have to give very detailed description of how we make sure that the data will remain anonymous. So we're not actually recording any characteristics that can identify individuals. And when we do, of course, there's a chance we make sure that it's being scrubbed of any sort of identifying information. And of course, it's still worrying whether we can, because we're still pre-planning for this, whether when we go to sites, whether we will run into concerned residents that may confront us. So we will be preparing information package and things like that, and liaising with the housing authority, who's recently given the go-ahead for this project. So from their point of view, luckily they have no concerns, but they let us negotiate with the residents themselves. But of course, on the plus side, there is a huge benefit to these kind of digital systems. If we keep them, let's say, in the domain of academic research, and we carefully use monitoring and surveillance and tracking of activities in a responsible way, because, and I hope we can convince stakeholders and public space managers of this purpose. Of course, if we can have a much more high resolution and long-term study of the actual patterns of behavior and activities in public spaces, we can have a much more detailed understanding of possible design solutions in how they might be suitable in relation to the real world needs. Yeah, I actually, I joined a bit too late, I suppose, in CUHK to talk with Adam about the Pavilion, but that setup is conceptually very interesting to also think about these kind of responsive systems where the robot doesn't just build one installation, but potentially can make changes over time as well, although we haven't actually talked or worked on that as such.
I think for the robotics construction project, it really is kind of operating on a bunch of different levels, depending on basically the time frame and the scale. So the thrust of the research has to do with the development of a new system driven by cables, which has to do with the kind of dialogue between designer and machine maker, which typically isn't the case. For example, it wouldn't be often that the architect is communicating with the crane operator or crane designer, for example, but suddenly this is the situation that we are in, and we don't know entirely what the limits of that machine are. So it's about a kind of actually similar to the workflow that we're talking about in systems development, where one of us proposes something and then the other one says, okay, well, that's almost possible. You update your version and then we update our version. Then there's a bigger layer of issues which has to do with the building department and making this a standard construction project. So in addition to satisfying our client, which happens to be the campus and CSPO and CBO and others, we also need to make sure that this satisfies government standards, which is what makes this such a really innovative project, in a first, certainly in the region, to have a permanent construction project implemented in Hong Kong, entirely done by a robot, or mostly done by a robot at least. So there's a couple factors that's in the immediate, let's say, 1 to 2 months of making sure that all of that is in order and approved with engineering and building department and in our AP and so on. And then beyond that, there is a more broad question about use, and in particular sustainable use. It is an environmental and a sustainable project to begin with, which is focused on recycling. So we need to make sure that as a product that we're creating for adoption by the campus and by its community, to make sure that it's successful in a number of ways in its use. And I think there's a lot of opportunity to coordinate laterally as well between researchers like Jeroen, who can monitor the surveil what's happening in a research-oriented way, but also in terms of how much energy it consumes, how much material we can effectively monitor and recycle through that upgraded brief, upgraded requirement. And I guess the other thing is that we have a patent on the system. So it can find its way into very different locations. It doesn't only have to be, for example, a full-blown construction project on a site. It could also be a guerrilla construction project in the forest if we want to find a different form that way as well. So the important part is the design setup, the control systems, and then all the motors and the servos can be reimagined or repurchased based on the individual requirements of weights, efficiency, distance, and so on. Yeah.
Yeah, great.
It's a long answer.
Yeah,
Hanjek.
it's very interesting.
Yeah, please.
Yeah, I had, hello. So thanks for Faculty of Social Science to organize this exciting series, and also thanks to my two colleagues to make this a very engaging and nice presentation. I have one question, looking forward to maybe what we could all do together in a way, because what I understand, our social science data lab, right, could of course be very, very useful for many of us. And one area that might be maybe interesting is basically the collection of social media data, no? Because I know from a conference that recently happened in Nanjing on the mobile urbanism and the mobile internet, that so much research is going on in mainland China at the moment with basically social media data. And we could see that basically Jeroen has to fly everywhere and have everywhere the cameras. But of course, if we all have these devices, we can basically collect the data also in other ways that could be also very efficient, particularly on a more kind of master plan or on larger scale, right? So basically, I would have a question both to our team here and but also to everyone in the Zoom space, or also to Bo Huang. Like, how is it possible to make those to collect social media data for our social science data lab, and on the other hand, maybe to brainstorm and so on, to see like what we could actually jointly in interdisciplinary research, or now also our speakers, what we could do with those kind of information. Yeah, that's from my part.
Yeah, maybe we, just very briefly, we just started with small experiments, right? With some data from Google. Of course, there's other people working with Twitter data. We already have OpenStreetMap. Other things are a bit more difficult to access, or they don't have geolocation data. So for instance, Flickr used to be great because that would post the timestamp and the camera information. But Instagram does not, for instance. So there's difficulties there, right? That colleagues, I'm sure, are familiar with. Researchers, for instance, in Singapore or in MIT, they have a chance to work with cell phone companies, right, to get mobile phone data. But this is very difficult, of course. So I would just pass on this question, I think, to the social science, because I'm also very curious about this, to see if they have experience with obtaining call data records or GPS location data or other kind of social media feeds in a way that can really build up comprehensive information models about urban ecologies.
So Dr. Bo Jiang, do you want to respond?
Yes, hi, I have
Please.
Yeah, I have a question. And first and foremost, thank you so much for the wonderful talk. And many thanks for sharing your research on the application of computational methods to enhance our built environment. I was very inspired by your research that used machine learning models to analyze social ecology and human motivation and aspirations informed by Maslow's hierarchy of needs. There's a long intellectual history on the intersection of the built environment and crime prevention as evidence in the crime prevention through environmental design perspective. Because safety from crime, fear, and victimization is such an integral part of quality of life, I wonder if you could share your thoughts on how computational social science could be leveraged to elevate livability from the role of basic infrastructure and habitat to providing residents with opportunities to improve their quality of life through the CPTED perspective. Thank you.
Thank you so much. That's an amazing, complex question, and it happens to be my PhD thesis. So I can talk a little bit about my view. Of course, there's many other views on this territory. It seems that you're very well familiar with the research done in the UK around social housing estates and in relation to crime. And yeah, if you follow the news in the UK, it seems still very relevant today. With, for instance, women's safety in the streets of London recently being brought to the forefront of attention, that even though we may feel that cities are becoming really safe, there's still at a subconscious level or in different areas still a very realistic sense of danger, or even the way people sort of evaluate spaces and in relation to other people, locations, and behavior. That is still very urgent to research more, and also where computational tools can help to understand. So I, for instance, have seen other people's research using eye tracking movement with little glasses to track the pupil, to understand where people are looking when they evaluate urban environments, which can also be tested in virtual reality. To understand, for instance, the impact of lighting or signboards. This was actually a paper in the Kadria conference. My own research is going quite deep into the psychology of the sort of fight or flight theories, right? And how people perceive, for instance, obstructed spaces, proportions of public spaces, in relation to their ability to have surveillance and control, or a feeling of control over space, or whether there may be areas they cannot see where strangers may be hiding. So there's actually an overlap between the environmental psychology and isophyst analysis, which is using point of view and tracking of line of sight in a computational mathematical way to analyze, for instance, different aspects of visibility. So we can map onto these sort of digital models of public spaces, which areas may feel more overwatched, or others that may not be as safe as we would like them to be. So there is a sort of a set of digital tools already out there, and people are working on, and I'm hoping to apply that towards Hong Kong, a very high density urban environments, where the three-dimensional aspect also plays an important role, especially when public space is becoming more constrained in the future. Yeah.
I think if I were to add a few things to that, an important thing to remember is that architecture in urban design isn't necessarily about new construction. It can also be about revitalizing what's already there. So through the kind of analysis tools that we are using or are interested in or have access to, and also the kind of immense processing power that might be required when we ask the right questions and compare and contrast different criterion, maybe about making small alterations to what's existing already, rather than the assumption, for example, not that you're assuming this, that an entire existing infrastructure or fabric should be renewed in its entirety for its optimum performance, for whether it's safety or general health, livability, walkability, etc. I think maybe Hong Kong doesn't always go that route for renewal.
Yes. Well, yeah, actually in the urban design program, we're actually Professor Hendrik is director and I'm teaching, we're looking at, for instance, a lot of not just safety, but also livability issues in new towns, and how a certain planning doctrine of, for instance, separating live and work or separating retail from living environments can actually reduce the livability and vibrancy, and therefore maybe safety out on the streets, right? So we're looking, for instance, at potential strategies to rejuvenate or upgrade existing new towns, rather than only focusing all the attention on the new development areas and just considering the existing spaces as fixed and final. Yeah.
Thank you. So just now I thought Bo Jiang would respond to Hendrik's question. So actually I can add a little bit. We can crawl the social media data from the internet. Yeah, for example, we crawl the data from Sino Weibo, and sometimes from Twitter, and sometimes we cannot get the contents of the social media messages, so we can only use the location of the check-in messaging. Yeah, for example, we use the Sino Weibo data and the Dianping data to evaluate urban vibrancy.
Right.
So the social media data can reflect kind of social activeness, and the Dianping reflect economic activities. So we combine them to evaluate urban vibrancy. Yeah, of course, if we can also crawl the content, then we can do text analysis to find the people's emotion, etc. Then perform some further analysis.
Yeah.
So any more questions from the audience?
Yes, can I have another questions?
Yeah, sure.
Okay, I wonder whether it's possible to extend this kind of training to vocational schools in Hong Kong, because because I think the quota for PhD students is very limited in our university, but there are many needs for technical training for young people, right? You mentioned. That's my question. Yes.
Well, I think really in terms of understanding how to access computation is really a question of literacy, a certain kind of literacy, I would say. And I don't think that it is exclusive to any particular age group at all. And there are certainly initiatives in STEM and STEAM that target very young children at probably age 5 or even younger to think computationally as well. And I think in my experience as a coder, probably since I was also a little boy, basically from the early 80s, the same principles are the same in terms of understanding the language and deploying it. So there's one component about teaching computational literacy, which has to do with computer code and understanding how to express yourself in kind of conditional statements and syllogisms and other things like this. At the same time, from the kind of top down, there is also quite a lot of development in more human language access points for computation as well. So you don't only need to know how to code in Java or C or native languages that directly interact with a chipset, but there are other kind of subsets from the English language, or it's typically English, unfortunately, but it's near human language that is another more accessible point. For example, when we teach here at the architecture school, we typically use a node-based visual language for teaching students how to code, for example. It's based on Python anyways, but it allows students to think about input and output in a linear way. It's called Grasshopper. It's very, very popular. It's become basically a standard for architecture offices. There's also a building information modeling BIM equivalent as well. We don't necessarily need to use that. It just seems to be the industry standard with the most plugins. I also have dipped down into more coding, for example, but in some ways it doesn't matter what the specifics are, as long as students are getting turned on to the idea of using that computer language. But I would stress again that it doesn't really matter where the access point is. If it were up to me, the high school students would have it already underway. And I'm sure if it was up to the high school students, they could go down and down and down. So regardless, we have a responsibility to introduce and expose students to technology and computer languages, and get them to understand that the job market, for example, that exists now will be entirely different literally here 10 years from now, or even 5 years from now. And the necessity for this upgrade in their digital literacy is actually quite urgent.
Yes, I agree with you. And also, additional question is for people who use the system. I know there are still those people in the age of 60s, 50s. They cannot read and write in Hong Kong. There are some, labor force in Hong Kong. They cannot read and write. So how can they use the system for their job? For example, they're working in the waste management system. If you use AI-assisted waste management system, how can they be involved rather than they lose jobs, right? And also construction workers, how can they, be adapted to this new kind of robotized, construction and without losing jobs? And also for those people who have disabilities, all kinds of, I'm considering those people who are less advantaged in terms of, literacy and their own abilities.
Yes. It's a very interesting discussion. And for instance, in architecture, we kind of force all the second years to at least take one course on digital media to have exposure to certain tools and get hands-on experience. But we always say that this is not software specific, and really for the purpose of trying to understand the logic and the way these tools plug into a larger sort of toolkit of skills and methods to allow people to be more adept and creative and powerful within the context of technology in the future. But at the same time, we don't expect that everyone will become a specialist in computational design, but just their first time exposure will allow them, for instance, in the future to collaborate within a team where some of them have developed further into becoming a specialist, but at least they have the same language, so they can engage in a more high-level conversation about which tools to use at which stage, or whether the outcome of the tool are actually valid, right? So we try to develop that kind of critical thinking around the tools rather than just go really deep into one specific methods. And I guess it's the same for high school or construction industry. Not everyone will maybe be able to handle all kind of technologies. But it's more about understanding that sort of collaborative team that is on site, and whether there's a project manager that helps communicate in a way that is really visual and really simple, or whether there's a sort of communication very seamlessly between a site office and a construction site through these tools such as augmented reality glasses and communication devices, etc. It's more about that whole ecosystem and how we can think about that critically and make small improvements that would already result in really great impact.
At the core of this is really instilling an idea of and an aptitude for problem solving, and a concept that seeking answers. I mean, there's my favorite analogy, which is every big problem can be broken down into smaller problems. But those, especially for young people, need to understand that those smaller problems may not always result in a success in the first time. So there needs to be a kind of hunger for and an aptitude for problem solving, for independently solving these problems and finding the answers for yourself. We've never had more access to answers before. When I was doing this, I had a book, right? And you couldn't necessarily find someone who had solved the exact computing problem that you were looking for. Instead, you would find example references. But now, with access to so much information, there are so many ways to penetrate forums, live chat groups, online chat groups, your colleagues. The last person should be your professor, for example. So there are so many ways to penetrate into this, this question of problem solving. And I think the benefit of that is the focus becomes more on the questions that you're asking and how we can think differently about things through repetitive kind of like failure and success and curiosity. And the access to computing is not that actually that hard at all, but it takes a small amount of bravery to get from an observer and someone who appreciates but doesn't engage to someone who really gets into it. And I don't think there's really an age group associated with it. And if you're 60 years old and you're still doing heavy lifting, I mean, that's a much broader question to, I don't think that computer programming will help that, I suppose. So, but I mean, honestly, Hong Kong needs to focus, and actually we're not alone in this. There are many other countries around the world that have a growing age gap, particularly in Japan, for example, where construction or any task, it doesn't matter, is getting kind of, some are being absorbed by automation, others are being assisted by automation. So it's really an interesting question.
Okay, great. So actually, I have a quick question. Okay. How can you account for low carbon concern in your design?
Interesting. Okay. One of the papers I wanted to discuss from the conference was in this, and I have to say, and it's no surprise that the construction industry, for example, is incredibly wasteful, and probably the biggest contributor to greenhouse gases, and has the biggest carbon, one of the biggest carbon footprints in all of the industries. And I just read a very interesting paper that I should bring up, basically that is talking about thinking about waste and efficiency as a data and computational problem. So we already have what is called building information modeling, which is a kind of object-oriented database, data-driven approach to building design, construction, lifespans, and even demolition. But not included in any of those object attributes, for example, is the carbon footprint or inefficient use of material. And there's a really interesting opportunity if the industry were to care about it, but certainly a pilot project happened in Melbourne, Australia, yes, Australia, I believe. I can share a link to the paper itself. Actually, Mark was, no, not Mark, but and Koisner. Yeah. Right. Anyways, it is possible to think about having an efficiency wallet that will never be at zero. It's not really possible in the construction industry, but at least as an attribute incorporated into the materials and planning, construction, fabrication, assembly, and lifespan of a building, it can be something that we at least consider. And it's an interesting frame to think about material use, because we already have a model existing that can adopt and incorporate material attributes and their efficient and effective use. I would mention one more thing about building information modeling is that it's really there to be transparent, which is why so many government projects are adopting the infrastructure to begin with. It allows for everything to be traceable and trackable, procurable, etc. And that doesn't happen in other versions of drawing tools or planning tools. So as we go from a paper drawing on a pencil drawing on a piece of paper, which has no value, it may have intellectual value, but it can't be translated and transferred. We slowly move up the scale of data, information, knowledge, and then meta knowledge or wisdom. We can start to bring other attributes and factors like efficiency and carbon footprint into that object model as we build our buildings or cities. Is that?
Nice.
Yeah, thank you very much.
It's a
So
long,
I was actually wondering if we just take a photo, then we can estimate the carbon emission, carbon consumption, etc.
from a building, or
Yes,
yes,
maybe outside the building or inside the building together.
yeah, there's
Yes.
a machine learning.
Yes, yes, that's also an interesting way of doing it. This is more from yes, that's also possible.
Yes, and of course there's also special infrared lenses you can even plug onto your mobile phone to take photos of buildings and actually see the heat leaking out through the facades. For instance, in buildings in Europe where it's a cold climate, or US, you can actually see where there's gaps in the insulation and things like that. And in the future, you'll be able to do that before the building is built, so you can actually still make improvements to the design and evaluate accordingly.
Yeah, I think the idea is that either you're extracting or siphoning data from a building without permission, for example, or you're already integrated into all of their systems as part of a building management and ultimately probably urban level management system. So yes.
Okay. Thank you very much. So any more questions? Okay, just one participant send in a question. Yeah, maybe similar to a question asked by someone. So he meant if the vulnerable groups cannot access the social media platforms, then how can account for their opinion or something like that?
Right. Yes. It's a very good point, right? And one of the limitations of using, for instance, cell phone data for urban studies, I think that's why many studies still prefer in some way, let's say, the old-fashioned, very reliable method of using human observers in public space, right? To make sure that everyone and everything is included. Yeah, also for opinion survey, I think interviews are still a sort of benchmark quality standard for inclusive research. But maybe it's also just a matter of time and also a matter of improvements in the technology and especially the user friendliness of those interfaces. So that eventually more and more people and more different types of people within society are able to have access to devices. I'm just thinking of, for instance, when I went to IKEA, there's a big stand with 3 buttons, green, yellow, and red, with the smiley faces on it, and everyone can just push one of the buttons to let them know whether the toilet was clean or not, right? So in the same way, maybe we can have similar devices, touch screens, etc., mobile apps that can be easily passed around, that literally anyone would be able to use without technical knowledge or training. I think that's a very important part of always, I think, designing a research project or even a sort of participatory process for sort of community design. Yeah.
Yeah, excellent. It's really fantastic presentations, and discussions are very impressive. Yeah, thank you all very much for your participation.
Okay, thank you so much.
That concludes this webinar. Yeah, thank you very much.
Thank you so
Okay.
much.
You're
Great
welcome.
discussion.
Yeah,
Bye.
Thanks, everyone.
bye. Bye.